Hello. So today I have another puzzle creation of mine. It's been a while since I actually constructed a puzzle, other than the ones I made for Jessica's birthday. So I thought inspiration struck, and I thought I would construct another one. So I hope you guys enjoy it. It's called Equal Sums, and it uses a rule set that I saw a couple days ago on Cracking the Cryptic. It was a solve by Simon, and the puzzle was by 28 Degrees, and it used this rule set that I hadn't seen before. Now, I don't know if 28 Degrees invented the rule set or if they just used it, but either way, it was the first time I had seen it. And I thought that there was some really cool potential with that rule set beyond what they had already done in their puzzle. And so I constructed this one, and I really like how it turned out. So I am recording a solve video for it. And please do check the links below, and you can try the puzzle yourself first. Definitely recommend doing that. Either way, you are welcome to watch me solve it here. I have a solve path planned out, although I'm sure it's not perfect. It should at least get you through the puzzle. So you could call this my intended path if you want to. And let me first go over the rules. So it's normal Sudoku rules. So we place the digits 1 to 9 in every row, column, and box. And other than that, we have these lines in the grid. And so what do the lines do? Well, you look at where they are in each box. So you can kind of think of the lines as split by boxes. So this line at the top here, if we look at the digits that end up in this line, say the digits end up being 2, 4, 6. Well, that would make them add to 12 within box 2. The digits on the line add to 12. And so here, the digits on the line in box 3 need to also add to 12. So in this case, we could do 7, 5, and that would work, because 7 plus 5 is 12. And so we have the digits in box 2 add to 12, and the digits in box 3 add to 12. So if we pass through 3 boxes, like this one, this passes through 3 boxes, we could say that these 3 add to the same as these 2, and both of them add to the same as this one here. So we have some similar lines going on here. Like, so these 2 would add to these 3. This one would add to these 2, etc. So those are the rules. And of course, we have this given 7 down there. And that's it. Otherwise, the board is blank. So do try the puzzle yourself. Again, the links are below, and I will go through my solve path now. So the kind of quote-unquote break-in to the puzzle that at least I intend is to notice that there are these 4 lines in the grid, and I'm actually I'll color them so I don't have to keep them highlighted here. So let's color those green. So these lines that I've colored green are special in that we have 3 in one box, 2 in one box, and then 1 in one box. And right now what we're going to focus on is the single cell and then the 3 in a box. And we're going to ignore the 2 in a box for now. So what can we learn from that? Well, this with this kind of acts like an arrow, except the arrowhead, if you've done arrow Sudoku before, the arrowhead isn't actually connected. So we have a single circle here, and then these 3 sum to that value. So what do we know about 3 cells? Well, the minimum they could add to is 1 plus 2 plus 3, which is 6, because we can't repeat in a box. So we know that this value here is at least 6. And then, of course, we know that it can't exceed 9 because it's a single cell. So that's true of all 4 of these. They all have a sum that takes 3 cells in a single box. And then these are single cells here. So these are a quad of 6, 7, 8, 9. And of course, this 7 is up here. So those can't be 7. So now, the next thing to notice, and I'm actually going to clear my highlighting for this, is let's take a look at column 1 here. So if we look at column 1, I'm going to highlight these in green now. So these are 5 out of the 6 cells that would sum to these 2. And the way to think about that is these 3 plus these 3 is going to be the same sum. So these 6 cells will sum to the same amount as these 2 cells, because we know that this sum is the same as this, and this sum is the same as this. So what that means is we can look at what these sum to minimum, and that would be 1, 2, 3, 4, 5, because they share a column. And the sum of the digits 1 through 5 is 15, And so this cell here is at least 1. And so we can say that the sum of these 6 cells is at least 16. So if one of these were a 6, the other one would have to be at least 10, and that's not possible. So these are not 6. So that makes an 8-9 pair, which means that this is a 6-7 pair. So now we actually know exactly that these add to 17, which means exactly these add to 17. So these are minimum 15, which means this could be as big as 2, but no larger. So that's a 1 or 2. And then these, they could be 1, 2, 3, 4, 5, adding to 15 with a 1 or a 2 here. Or they could be 1, 2, 3, 4, 6, adding to 16 with only a 1 here. And those are the only options because we have 1 degree of freedom. So there's always a 1, 2, 3, 4 within these 5 cells, and then either a 5 or a 6. So we can actually put here that this is 5, 6, 7, 8, 9. All right, now we can look at the other side of the grid, and we can see that this is a 6 or a 7. So these 3 cells, if they added to 6, would be 1, 2, 3, and if they added to 7, would be 1, 2, 4, and it's the same up here. So these are from 1, 2, 3, 4, and we know that all of them contain a 1 and a 2 for sure. So we can't repeat a 1 or a 2 in the rest of this box or the rest of this box. And indeed, in these 2 columns, how many 1s and 2s do we have? We have exactly 2 1s and 2 2s in these 2 columns. And these 3 cells have 1 of each of 1 and 2, and these 3 cells have 1 of each of 1 and 2. That accounts for all of our 1s and 2s in these 2 columns. So for this third column, we can't have a 1 or a 2 here. We can't have a 1 or 2 here. So 1 and 2 are limited to column 7 in box 6. All right. So next, we can ask the question of where do the low digits go in box 4? And by low digits, I mean 1, 2, 3, and 4. We'll call those the low digits. So let's take a look at, first of all, we know in column 1 they can't be there, and that was because they had to be in these green cells. And I can get rid of that coloring now, so it's not confusing. And so the 1, 2, 3, 4 are going to be in these 6 cells here. Now, can we repeat them here or here? So can we have 2 low digits here? Well, the highest 2 low digits can add to is 3 plus 4, and that's 7. And we know this is 8 or 9, so that's not big enough. So we have at least, or at most 1 low here, at most 1 low here. And so we have 2 more lows to account for. And we actually, if you think about the math, we're going to have exactly 1 low in each of these. And so that leaves 2 more lows. So these 2 must be low. They must be from 1, 2, 3, 4. And if we look at box 5 now, we know that we have this 6, 7, and 8, 9. So 1, 2, 3, 4, 5 is what's left in this box. And I'll go over this in a second, but you can see this makes a 1, 2, 3, 4, 5 quintuple in this row. So this can't be 5. These are from 6, 7, 8, 9, which means this can't be a 1 or a 2 anymore. And so that leaves a hidden 1, 2 pair in this column here, or in the box, I should say. Box or column, it works either way. And we can see that 5 is limited to these 3 cells of our 1, 2, 3, 4, 5 quintuple. So the 5s cannot go in these 2. Finally, if you notice this cell here, this is the same as the sum of these 2 cells. So it works exactly like an arrow, where the arrow circles here, and then the arrow itself is these 2, the line is these 2. And so the minimum here is 1, 2. That would add to 3. So these can't be a 1 or a 2. And then it maxes out at 4. So this could be a 1, 2 or a 1, 3. Either way, it does have a 1 in it, so this can't be a 1. And this is 3 or 4. So next, what I'm going to do is take a look at these 2 cells, because we know that these are 6 and 7. So we know that 1 and 2 are going to be in these cells. So how do we achieve 6 and 7 here? Well, thinking about the 1, what would happen if the 1 added to 6? Well, that would mean I'd have a 5 here. So let's say I'd have 1, 5 here. Well, with a 1, 5 here adding to 6, that would leave a 2 here adding to 7, and that would also require a 5. So that's not going to work. So I can't actually involve 5 in the sum to 6. So the 1 is going to sum to 7, and the 1's going to sum to 7 using a 6. So the 6 is going to be in one of these. And then that leaves the 6 using the 2. And so that's going to be a 4, 6 pair. So with that 4, 6 pair, we get a lot. So these can't be 4. If you remember, one of these is 1, 2, 3, and one of these is 1, 2, 4. And these can't be 4 anymore. So this 1, 2, 3 triple. That tells us that the 3 is going to be in column 8, which means the 3 can't be in column 9 also, because we only have 1 3 in these 6 cells. Because we have 2 1s, 2 2s, a 3, and a 4. And so the 3 can't be here. So we have a 1, 2, 4 triple now here, and a 1, 2, 3 triple now here. And then finally, this 4, 6 pair does eliminate 6 from these 3. And so this actually places a 6 here. Now none of these can be 6, and that, you can see this is spiraling out. So none of these can be 6, and now we know that these actually are a 1, 2, 3, 4, 5 quintuple. So these can't be 5. That's a 7, 8, 9. 1, 2, 3, 4, 5 adds to 15. We know this adds to 17, so this has to be a 2. That removes 2 from both of these. This can't be 2 anymore. And coming back to this box here, we do have a pair left here. That's 3, 5. So now let's look at this 3 or 5 here, because we have this on this line here. So the question is, what can be on the rest of this line? So it's going to be a 6, 7, 8, or 9. And what is the minimum that these two add to? Well, 6 plus 7 is 13. So at minimum, these add to 13, which means this can't be a 3, because that would mean this cell has to be at least 10. So if this isn't a 3, that places the 5 and the 3. This can no longer be 3. And now we'll do just this 2 here. We didn't clean up these 2's here, which means we know that there's a 2 somewhere down here in this box here. So there's a few things you could do next. The one that I like is actually looking at row 9. And we can ask the question, where do 8 and 9 go in row 9? So first, they could go here. That's pretty clear. Could they go here? Well, so let's say I put an 8. It doesn't matter where I put it. Let's just look at these 3. If I put an 8 here, what is the minimum that this could then sum to? Well, it would be 16. And so that would mean that this would also sum to 16 or more, and obviously it maxes out at 17. So this would be a 1 or a 2 with the 8, and this would have to add to 16 or 17, both of which use a 7 or an 8. 16 would be 9, 7. 17 would be 9, 8. And so putting an 8 on here is actually not possible. Well, can we put a 9 on here? You can probably guess it's not. We'd have to put a 1 here. That would make this add to 17. How would we make this add to 17? Well, we'd need to use the 9 again. So 8 and 9 cannot go in these two. 9 obviously can't go on here, because if I put a 9 here, what the heck can I put here to this would sum to the same thing? Can't put a 0. And so what about 8? Well, 8 would have to go with 1, but we know 1 is on this line here. Add 2 is as well, in fact. And so that means that the 8 and 9 can't go here, the 8 and 9 can't go here, so we have a hidden 8 and 9 right here. So now 7, 8, and 9 are used. We know this adds to 17, so these two then add to 10, because we have 7 accounted for. How are we going to add to 10? Well, we can't do 1, 9, we can't do 2, 8, we can't do 3, 7. That leaves just 4, 6. That 4, 6 pair, this is actually resolved. This is a 4, that's a 6, because of this 6, 7 pair. And this 4 eliminates 4 from here. 4 is eliminated from here. And these are from 1, 2, 3, 5. So now if you look, we have a 1, 2, 3, 5 quadruple in box 9. And so this has to be a 4 because it can't be 1 or 2. That tells us now that this is the 7, so it can't have a 3 on it. So this is 1, 2, 4. That means this is a 7. How did we add to 7? We did 1, 6. And then we can't resolve this 1, 2 yet, but it is a 1, 2 pair. So that means that's 3, 5. That places this 8. And that 7 now means this one's a 6. That means this is 1, 2, 3. So this cannot be a 4. And this now has to be 2, 4. And now this 4 that we just placed, that makes this cell a 3. And so now we know it adds to 3. The only way to do that is with a 1 here and a 2 here, because this cell can't be 2 because it sees a 2. So that's a 1, that's a 2. That 1 sees over, that makes that a 3. This sees a 2 and a 3, so it's a 1, that's a 2. The 2 sees down, that makes that a 1 and a 2. These can no longer be 3. That means one of these is a 3. This cell here now sees a 2 and a 4, so that makes this a 5. That eliminates 5 from these. So now what we can do is we can look at this line here. And so these 3 have to sum to these 2. So if we didn't use the 4, we'd be a 1, 2. These can't add to 3. In fact, these add to a minimum 6, and these add to a maximum 6. So we can just say this is a 2, 4. The 1 goes here, and this is a 1, 2, 3. These can't be 2, so that places this 2 here. And this 1 sees down, so that's 3 and that's 1. These now can't be 1, so they're from 2, 3, 4. And next what we can do is we can look at how are we going to fulfill these 8 and 9 sums. So first of all, this sees a 7, and so what's left for the row is 2, 4, and 5. So the only thing we can add up to is 9. 8 isn't possible anymore, so this isn't a 2. That's a 4, 5 pair. That means this is 9, this is 8, this is a 2, 3 pair. That places the 4 and the 2. And this is not an 8. And how are we going to add to 8? Well, we need to use the 1, so it's got to be 1, 7. That makes that a 9, 8, 7. And since we know now this is 9, and this is 8, the 8 is actually more interesting, because we know it contains a 2, and we know 8 must contain a 1 as well. So it's going to have a 1 and a 2. And that adds to 3, obviously. And so we have to put a 5 as well to round it out. So this is going to be 1, 5, 2. We actually know the order because of that 1. So that's 5 and 1. So this is a 2, 3, 4 to make the 9. This sees a 2 and a 3, so that's a 4. This sees a 2 and a 4, so that's a 3. That's a 2. So we have this whole column done. Next, we see this 2 looks down, so that's a 3 and a 2. And we know that this now adds to 13. And so the only thing this can be is 6, 7, because the 8 and 9 is used up. 6 plus 7 does add to 13. It's the only way to make 13 without using 8 and 9. And so these remaining are 1 and 5. We actually know the order. This is a 5, this is a 1. Remaining in this box is a 5, 9, and the 5 sees over, so that's a 9, that's a 5. This is no longer 9. And this is going to be, let's just fill these out. These are from 6, 7, 8, 9. That's not a 9. These aren't 8s. And this 6 looks down. All right, so again, there's probably more that we could do at this point, but what I like to look at next is this line here, and look at it more closely. Can this contain a 9? And you can see pretty quickly that it can't, because the minimum it would add up to is 9 plus 6, which is 15. This has a 5 on it, so this would have to be a 10 or higher. So this can't have a 9 on it, and so now in this column, where does 9 go? It's hidden here. This must be a 9, so these are not 9. Now we know this adds to 14. The only way to add to 14 is with 6, 8. That puts a 7 here. That's a 9. That's a 6. That's an 8. 7, 6. And we're almost done with the bottom 3 bands, actually. This 3 actually does see down, so we can get the 5 and the 3 as well. And so next, you can see this column's almost done. It just needs a 3, so we place the 3 there. And we can see that this must be a 7 or an 8 to complete the column, but it sees an 8, so this has to be a 7. That's an 8. That's a 7. So now we have these 2 7s looking into this box, and this 7 that's given looks up, so that's a 7. We also have these 2 3s looking in, and this 3 looks up, so that's a 3. And so now we just have some, I'm just going to go full candidate for its remaining. This is 4, 5, 9, and this can't be a 5. This column needs an 8 and a 9. This column needs a 4, 5, and 6, and again, this can't be a 5. This column here, well, we see it has a 1 here, so this can be a 7, 1. And this 5 sees up, so that's 4 and 5. And so what's remaining is 6, 8, 9 here, and in this column we need 4, 8, 9. And there's not much you can see without dealing with this. You can see that there's a 6, 8, 9 triple here, so we can get rid of the 9 from there. So the last thing to look at here is this line here, and that's going to disambiguate the rest of it. So the question to ask is, what is the minimum these 3 cells can add to? Well, it's 3 plus 4 plus 8. That adds to 15. And so these 2 must also add to at least 15. Well, you're not going to use a 4 or 5 with that, so this must be a 9. That places 4 and 5. That places 6, 8, 6. These can no longer be 6. This has just a 9 remaining, so none of these can be 9s. And this 9 sees over. That places an 8. That's a 6. That's an 8, 9. This is a 4, 5, and 4. And just to double check, 8 plus 5 plus 3 is 8, plus another 8, that's 16. That adds to 16. And don't forget the bottom here, this is 8 and 9, and we're done. So that is how you solve my equal sums Sudoku. I hope you enjoyed solving it yourself, or at least enjoyed watching my solve of it. If you liked the video, make sure you actually hit that like button. Feel free to leave a comment, help the algorithm out. If you're not subscribed, please remember to subscribe. I'm trying to get to 1,000 subscribers. We're on our way. We're over 700 now, so that's awesome. And if you check the description, if you enjoy my content, you enjoy my streams, I do have a Patreon that you can sign up for. There's only one tiny bonus to having the Patreon, which is you get a special chat channel in my Discord. You can check also the description to join my Discord if you'd like to. Really, it's just a way for people who want to support my stream to do so on a monthly basis. You can pledge $1 or more, however much you'd like. There's just a single tier, and that is the only reward at the moment. So again, I hope you enjoyed this, and thanks for watching.